obviously not be able to grade it if you turn it in Tuesday morning. So you're then allowed to ask me to do any question on the homework that you had trouble with. Remember, you are answering the homework, looking at the answer. If you get it wrong, you're going to try it again. Maybe it's algebraic that you have to do. And you can send me a question, right? Or then ask me Tuesday to answer it. So differentiation, and let's take a look right away at some implicit, right? I like 13. Let's do 13. It's kind of nasty, but let's see how we do with it, okay? So e to the x over y equals x minus y. And we want to find y prime in terms of x and y, okay? So I'm going to tell you, I want you to find the derivative, right? Or I want you to find a slope. If I say find a slope, that means I don't care about y prime, okay? I'll try and do one like that as well on Tuesday. So e to the x over y equals x minus y. So this is 3.5, number 13. E to the x over y equals x minus y. So I've got to take, I can't solve for y here, right? It should be kind of obvious, right? How would I solve for y here? How would I get that stuff out of the exponent? Yeah. So how do I get the y out of there?
You divide e to the x divided by e to the power y.
I think I could do. Yeah, I would take the ln of it. I would do the ln, right? I have to get the e out of there. To get the y by itself, I have to get rid of the e. So I would go with the ln. But then what happens on the right side if I take the ln? The x and y get locked in the ln. So they're either locked in the function e to the x, or they're locked in the function ln of x. Is that making sense, what I'm saying?
Yeah.
So I can't do anything with this except for implicit, okay? So I'm going to do d dx of both sides, right? So e to the x over y, and that should equal d dx of x minus y. Well, on the left-hand side, it's chain rule, right? Because I have e to some crazy function, right? So when I do my derivative, I get e to the x over y times the derivative of x over y. And I'm putting a placeholder in that because I want to use a quotient loop there. And on the right-hand side, what do I get? 1 minus y prime, right? Derivative of x is 1. Derivative of y is y prime. We've been doing that for a long time now, right? So this implicit is really nothing new. It's pretty easy, but you got to be organized, right? So I'm going to get my product loop. Upstairs function is x, derivative is 1. Downstairs function is y, derivative is y prime, and I need it over y squared. So what do I get? E to the x over y times y minus xy prime, right? Double check me there. Y minus xy prime divided by y squared equals 1 minus y prime. Everybody agreeing? Everybody with me? I have to solve for y prime. There's no easy way to do it. I'm going to have to distribute some things. So I'm going to do my e to the x over y divided by y squared times y minus e to the x over y squared minus xy prime. Times xy prime equals 1 minus y prime. Make sure you see that I distributed the green pieces, right? I distributed the green pieces. I can now get all my y prime terms on one side. Yes, everybody with me? I can get all of my y prime terms on one side. I'm trying to minimize the number of negatives, but this doesn't give me many anyway, so it's fine. So I'm going to go y prime minus e to the x over y squared times xy prime. So I moved all my y prime terms to the left and everything else to the right. And of course, one of my y's canceled there, right? We okay? Factor out the y prime. And then divide by that to solve for y prime. Oops, sorry. Now, am I done? No. What's making you think I'm not done? I have fractions within fractions. So I'd like to clear those fractions. And I want to solve in terms of x and y. I don't want the base e in there. So first of all, I need to multiply by y squared over y squared. So I get y squared minus y times e to the x over y. And then I get y squared minus y squared minus x e to the x over y. I mean, that's a perfectly fine answer. I can factor a y out upstairs, so I'd probably like to do that. But I know what e to the x over y is, right? It's x minus y, so I can make another substitution. So I get y squared minus y times quantity x minus y over y squared minus x times quantity x minus y. I probably want to distribute things out and see if there's anything else I can do. It does look like I can factor out a y upstairs, but not much downstairs. So let's see what I get. So I get y squared minus xy plus y squared. Nice. Y squared minus x squared plus xy. Cool. So I can keep going. I get 2y squared minus xy over y squared plus xy minus x squared. Just looks better to me that way. Descending powers of y, ascending powers of x. And then I can factor out a y upstairs. Yuck. Nasty.
How do you know when you're done?
When you've got everything factored, when you have a single term completely factored. I can't factor that downstairs term. It'd be nice if I could, but I cannot. Let's see, who else just came in here? Rosie's here. Daniel's here. Grace is here. Ian is here. Marco is not. Delion is here. Emerson. Doan, nice. That's a lot. lot to write, right? But you don't need to copy, you need to do it yourself. See if you get the same result. What's nice about that problem in WebAssign is it's there, right? And so that you can see they took my answer, right? They stopped it before I put in the substitute for e to the x minus y. But that's fine, right? I could say to you, find the y prime in terms of x, y, and e to the x over y, right? Cool, let's do one from last class. So I was going to do number 10. Oh no, that's not the one I was going to do. I was going to do something else, but that's kind of boring. Oh, let's do, no, sorry. Decide, Robert. Oh yeah, I was going to do 17. Let me do 17, and then let me do something like 21. It's kind of boring when it's when the inside function is not interesting. Maybe 23. All right, let's do 17 first, okay? So I have the inverse tan quantity squared. So this is 5.6, number 17. So I've got y equals inverse tan of x quantity squared, right? There's no other way to write this, by the way. Well, I could use arctan inside, right? This is the same as arctan squared of x. That one's a little bit nicer. You can see why I like the arctan notation. I cannot write, like when we have cosine of x or cos squared of x, right? I can use the arctan the same way. So the first thing I see is I have an angle, right? How do I know I have an angle? Inverse trig. Inverse trigs will always give me an angle, but I don't think in terms of inverse trigs. I think in terms of trigs. So I want to take the tangent of both sides, right? Well, the tangent of the inverse tan are going to cancel. So I get tan of theta is equal to x. And that piece is going to give me my right triangle. We've seen this one a bunch of times already, right? This side is x, the adjacent side is 1, the hypotenuse is square root of the quantity 1 plus x squared. Nice, I'm ready to take my derivative. Most likely, I'll have to go back to the triangle. So I want to find y prime, right, in terms of x. Well, it doesn't really look like I'm going to be able to. So let me just say, let's find y prime, okay? Because I think I have an issue here. I kind of want to think of this as theta squared. So what do I get for my derivative? 2 times theta times theta prime, right? 2 times theta prime. Well, what's theta? It's the inverse tan. So 2 times the inverse tan of x, I don't think I can change that at all, right? Times the derivative of the arctan, which we have memorized, yes? 1 over 1 plus x squared. So there's nothing else I can do with that one. Done. Didn't need to go back to the triangle, correct? I said 90% of the time you'll have to go back to the triangle. We okay? Nice, let's do another. Let's do 30. No, that's boring. $33, $32 looks horrible. Let's do 33. 33. And it wants me to find the slope at 2, right? Okay, we ready? So 3.6, number 33. So I've got y equals x times the arc sine of x over 4 plus the square root of 16 minus x squared, right? So find y prime and y prime of 2, right? So find the slope at 2. Yes, you with me? This is an x over 4. Nice, so my very first piece of my function is a product rule for the derivative, right? And the next piece of the function with the chain rule, and the next piece of the function is a chain rule, right? So I got a lot of work to do here, yes? So let's see if I can work on my product rule first. So the first function is x, derivative is 1. Second function is arc sine of x over 4, right? And for that, I need a u sub, right? Remember, if y equals the arc sine of u, y prime is u prime over the square root of 1 minus u squared, right? I've got this written down. I've got this memorized. We derived it, right? We found out it was true by using implicit. Now you're just going to memorize and use it. But I need what? What do I need to use that formula? I need a value of u. What is the value of u? X over 4. What's u prime? 1 over 4. Remember, an mx, right? And what's u squared? X squared over 16. So I get for the derivative, I get 1/4 over the square root of 1 minus x squared over 16. So this is going to be my product loop. Nice, we're ready for our derivative. Ready? Anybody not ready? Nice, so y prime is 1/4 x over square roots of 1 minus x squared 16ths plus arc sine of x over 4 plus 1 over 2 square roots of 16 minus x squared times what? Times a negative 2x, right? That last piece is the chain rule. Yes, you with me? We okay? We got to do a little bit of arithmetic here. You see I have fractions within fractions, right? So that 16 I have to manipulate over here, right? You with me? I want to get a common denominator, so I'm going to get a 16 over 16 here. And now I can rewrite everything. Y prime is 1/4 of x divided by 1/4 times the square root of 16 minus x squared. I'm going to cancel these 2's. And notice what else cancels the 1/4. Where did I get that downstairs 1/4 from? Where did I get that 1/4 from? Square root of 16, yep. So the 1/4 cancel, right? And then I can see that these two pieces cancel. So final answer, y prime of the arcsine of x over 4. Nice. And what does it want me to do? It wants me to find the slope at 2, right? So y prime at 2 is the arcsine of 2 over 4, which is the arcsine of 1/2. And of course, we know that reference angle is pi over, damn it, pi over 6. Morning, Marco. All right, let's do the new section. What?
How we do for the x over root 16 minus x squared.
Yes.
What did you say the quarter to the denominator?
Is that Ian?
Yeah.
Yeah. Are we here? Are we here?
No, the next step.
The next step. So not here either.
Okay. Yeah. So that.
Okay. So if I just zoom in on that, okay. If I see I have a square root of 1 minus x squared over 16, I want to get a common denominator, right? And so now I can see that I have square root of 16 minus x squared over 16. That 16 downstairs can come out of the square root, right? So there's the 1/4 times the square root of 16 minus x squared, right?
How doesn't that change the top?
What's that?
How doesn't that change the top?
Because I'm multiplying by 1.
But I think you know that.
Yeah, I'm just multiplying by 1. Whenever I multiply by 1, I don't change anything. It's weird.
Can you go back up a little bit?
Yep.
But don't you have to multiply the other side? But shouldn't it be like 16 minus, like,
Well, the other side already had a 16 in the denominator, right? So all I have to do is I'm getting an LCD, is what I'm doing.
okay.
Yep, nice. So you can't avoid doing these problems. They're going to show up on the test, so you've got to make sure you do them, right? And if you're having trouble with them, you've got to ask for help. You can ask me, you can ask the Math Learning Center, you can ask Online Learning Center, you can ask Dr. Early, you can ask your study group, right? You can ask Mr. Google or Siri or whoever you use, right? All right, today's lesson is very quick, okay? Very quick. And we're talking about the derivative of the ln function, okay? Now, some teachers will teach every base. I only teach log base e, right? So this is section 3.7, derivative of log functions. So if y equals ln of x, we know the shortcut, right? We know the shortcut. The shortcut is what? Y prime is 1 over x, right? But how are we going to show that if we don't know how to take the derivative of ln? So what we do is we use the inverse function, right? Because now that we know how to take a derivative of inverse functions, we're all set here. What is my inverse function here? Base e to the x, right? So e to the y had better be equal to e to the ln of x, right? But what happens on the right-hand side? E and ln are what to each other? They cancel. They're inverse functions. So I get e to the y is equal to x. And now I want to take the derivative of both sides, right? So I'm going to do d dx of e to the y should equal d dx of x. Well, no, I'm sorry, of y, right? Sorry. Yes, you with me? Well, on the left side, I got to do, I have to do implicit, right? So what do I get? E to the y times y prime. And on the right-hand side, I get 1. I'm solving for y prime. So I get y prime equals 1 over e to the y. But do I know what e to the y is? Look at the page. X. So there it is. It's 1 over x. So we have two shortcuts that we want to memorize now. Right? If y equals ln of x, y prime is 1 over x. And if y equals ln of u, y prime is u prime over u. There are our new versions. Okay, that's the lesson. Let's do some problems. That's it. There's not much to it, okay? So, but let's look at a couple problems. Yes. Sorry. You got it? Oh, I don't want to zoom too much because I'll lose, but I can give you a split screen of it, okay? Good? And that's the rest of it. All of the things I did there, right, are from our pre-calc class of using inverse functions, right? Again, the book will have a lot of questions like 2 to the x or log base 2. I'm not doing any of those. You will not see any of those on my tests or quizzes. So if you want to do those, look at the formula for b to the x, derivative of b to the x, and log base b to the x, right? They're in the book, they're in this section. I stick generally only to e to the x and ln of x, okay? Again, I'm trying to simplify as much as I can. Trying to cut some things out. All right, let's do a couple problems. So section 3.7. So look at number 6, log base 5, right? I'm not doing that at all, okay? Let's see if we can deal with this one, number 11, okay? I'm going to write it here. So this is 3.7, number 11. Godzilla. Y equals the ln of a fraction, 2x plus 1 quantity cubed over 3x minus 1 quantity to the fourth. Well, if I do this derivative the way that I just taught you, it's absolute hell. But I'm going to do that, and then I'm going to use what I call the ln trick to solve this, okay? So I want to remind myself that if y equals the ln of u, y prime is u prime over u. So I just had to figure out what u is. U is that entire inside. Do you see how hideous it's going to be? Find a derivative. Yep. Yes, I am recording. So you can see u is going to be quotient rule, right? Well, there's no way to avoid it. I'm gonna do it, right? So u is 2x plus 1 quantity cubed over 3x minus 1 quantity to the fourth. So upstairs function 2x plus 1 to the third, derivative 3 times 2x plus 1 all to the second times another 2. Where the heck did that extra 2 come from? Derivative of 2x plus 1, right? Derivative of 2x plus 1 is 2. My downstairs function is 3x minus 1 to the fourth. So derivative is 4 times 3x minus 1 to the third times another 3. And I know I have to divide by the downstairs squared. So to the 8th power. Now I've got my u prime. I already know the u. I'm ready to write out this derivative piece, right? So I get y prime is upstairs. I need the derivative. That's going to be this quotient rule. I have 6 times 2x plus 1 quantity squared times 3x minus 1 quantity to the fourth, minus 12 times 2x plus 1 to the third times a 3x minus 1 to the third. Everybody with me there? I need to divide by that downstairs squared and then divide by u. Oh my God. Horrible. I got a couple of choices, right? And you don't have to do your algebra the way I do mine. So I could keep change flip right away, right? Which is not a horrible thing to do. I still have to factor upstairs, right? I still will have to factor upstairs. So this is a good one for you to finish on your own. I want to take the shortcut. So I'm not going to finish this one this way. I want you to. I want you to do it, okay? So, but I'm going to use my ln trick. So dot, etc., or excedrin, because you're going to have a headache after this one, right? So you finish it. I'm going to do the ln trick. All right. Using the ln trick. This is my words. It's not, they don't say it in the book. They still use it. Just a shortcut way for me to say it. If I look at y as the ln of that horrible fraction, I can use the properties of the logs that I learned in pre-calculus to make this easier to deal with. And that is the ln of a quotient is the difference of ln's, right? So this becomes what? Ln of 2x plus 1 to the third minus ln of 3x minus 1 to the fourth. You remember doing this in pre-cal? Those exponents inside become coefficients. So now I have 3 times the ln of 2x plus 1 minus 4 times the ln of 3x minus 1. Yes, you remember this from pre-cal? All those properties of logs? Just lie to me. Yes, you do? Good. Now I'm ready to take the derivative much easier, right? So here we go, y prime. 3 times, what's the derivative of the inside? 2 over the inside. Oh my God, look how much easier that is. Minus 4 times, what's the derivative of the inside? Over the inside. Easy. So now I'm not done. I have more than one fraction, right? So I want to get an LCD here. I get 6 over 2x plus 1 minus 12 over 3x minus 1. I need an LCD, so I need a 3x minus 1 over itself here. And I need a 2x plus 1 over itself here. Everybody okay? Well, now downstairs, I definitely see, right, that I have my LCD. I have a 2x plus 1 times a 3x minus 1. And upstairs, I'm going to want to factor. Right away, I can take out a 6, right? So I've got a 3x minus 1 minus 2 times a 2x plus 1. So I took out a 6 there, upstairs. And now I got to simplify inside there. So it looks like I get a 3x minus 1 minus 4x minus 2. Double check me there. I factored out a 6, right? So there's like really a 1 here. 6 times 1 is the 6. Yep. So it looks like I have what? Negative 1x minus 3, right? And that's fine for an answer. It is a little bit nicer to take out the negative upstairs as well. Oh my gosh, so much easier than all that factoring in the other one, which is why we have this ln trick. It makes something as horrible as that product problem we did today that Diego gave us, or a quotient problem like we had here, right? I think it's good for you to practice the factoring version because that's what's going to be on your midterm.
This is just two less lines.
Well, say it again.
This is 2 lines less.
Yeah. Yeah, but the factoring is bothering some students. All right, let's take a 5-minute break and then we'll take our quiz today. So come back in 5